Next, let's look at the organic molecule formaldehyde. The chemical formula is CH2O. Here there are 3 atoms present. We'll count the total valence electrons first. 1 carbon atom, 2 hydrogen atoms, and 1 oxygen atom give us a total of 12 valence electrons available for bonding. The least electronegative atom goes in the center. We can also use a shortcut here. Typically, the first element will go in the center. Around the carbon, we'll draw the 3 other atoms. And we'll add the connection to show the covalent bond. 3 bonds equal 6 electrons used. There are 6 electrons remaining. We'll use those 6 electrons to satisfy the octet rule from the outside going in. Hydrogen is satisfying the duet rule. Notice that oxygen is forming 1 bond, so it needs 6 electrons to satisfy the octet rule. Using 6 electrons, we have 0 electrons remaining. Notice we have a little problem. Carbon does not satisfy the octet rule, and there are no electrons remaining to add to carbon. Here we'll move to step 5. Lone pairs of electrons may be moved between atoms to form extra bonds, only to satisfy the octet rule. Here we are forced to move a pair of electrons from the oxygen in between the oxygen and carbon. This allows us to form the extra bond between carbon and oxygen. Notice that the new structure has the octet rule satisfied for both the carbon and the oxygen atoms. This is the Lewis structure for formaldehyde. This includes the double bond between the carbon and the oxygen.